Okay, so in this video, we're going to look at how to do complex numbers in your TI-83, 84 calculator. In this case, you're going to activate the complex number operations by going to the mode screen and then scroll down until you get to the line that says real on it. You're going to scroll over to the A plus BI and hit enter. Now, when this receives the highlight, then you can hit second quit to return back to the main screen. Now, once this is activated, you don't need to ever turn it off again because it won't affect the way real numbers are calculated, which is what you're going to do most of the time. And it will just allow you to get answers that are complex and without necessarily getting an error on the applications on the main screen, and it will allow you to do calculations with complex numbers. So, for example, you can do all sorts of operations on complex numbers from here. So if I want to add two complex numbers together, I can just write out the problem on the calculator screen, 4 plus 3i plus 5 minus 2i, and then to get the I, that is second, and then the decimal place key, the I is right above that. And when you get that, it's going to add the 4 and the 5 to get 9, and it's going to add the 3i and the minus 2i to get I. If you're just adding, you don't need to put the parentheses in here, but if you're subtracting, at least on the second one that follows the subtraction sign, you should put the parentheses around it so that it will properly subtract the second term as well as the first term. You can also do multiplication and powers on your complex numbers. So here I did 3 minus I squared plus 3 plus I. And so I'm getting, again, it's foiling this out and then it's adding these terms and I'm getting 11 minus 5I. Now, more complex operations can also be done. And so one application of doing complex numbers is with the Mandelbrot set. The formula for a given number in the Mandelbrot set is to take our starting value, our seed value, for our starting value for a particular step. We're going to square it and then add whatever our constant seed value is. And then we're going to, that's going to get us the next term in the sequence. And then we repeat this process. So for example, if we use this value, 1/2 minus 5 over 6i as our initial starting value, then if I just type this into the calculator, you'll notice it converts to a decimal place. You can use the convert to fraction key to convert your complex numbers back to fractions as long as it's something that the calculator can handle, like up to 2 or 3 digits. Now, if I want to follow this sequence and find out if this initial point is inside the Mandelbrot set or not, I need to see what happens to the sequence of values as I keep stringing it through this formula. So what I'm going to do is I'm going to use my answer key, second, and then the negative sign to call back my answer from the previous line. Then I'm going to square that, and then I'm going to add back in my initial seed value. And for this example, I'm going to then hit enter, and it's going to, again, square that and that previous value and then add this number back in. And then I'm going to keep hitting enter because this is going to take my now previous answer and add that value back in, and then again and again. And what I want to see is, does the values in my list here stay small, or does it get bigger and bigger and bigger? And if it starts getting bigger and bigger and bigger without bound, then I would conclude that this set is not in the Mandelbrot set. If it stays contained and small, then it would be inside the Mandelbrot set. And we see after a couple of calculations, the numbers start to get bigger. Generally, once you exceed the value of 4, you conclude that, in fact, the magnitude of a value of 4, you conclude that this is, in fact, not in the Mandelbrot set. It is exploding and it's not included anymore. If you were to get something again that stays small, then that would be included in the Mandelbrot set. Again, that's just an example of doing something somewhat complex with our complex numbers.